In the previous lessons, we've been talking about proving our triangles congruent using some shortcuts. So I just wanted to take a second to kind of review what shortcuts there are that will work to prove triangles congruent. The first shortcut that we had discussed was using the side, side, side shortcut. And that same day, we also discussed using side, angle, side. In addition to that, in lesson 4.6, we said that we could also use the shortcuts of angle, side, angle, 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 side, and finally, hypotenuse, leg. Now, not every combination will work to prove triangles congruent. So we had also discussed that angle, angle, angle is not going to prove our triangles congruent, as well as side, side angle is not going to prove our triangles congruent. Well, today we're going to work on some more proofs, but they're going to look a little bit different. Today we're going to work on proving some of the parts of our triangles congruent, segments congruent, or angles congruent, and we're going to use an abbreviation. That abbreviation is going to be CPCTC. Well, what does CPCTC stand for? CPCTC stands for corresponding parts of congruent triangles are congruent. We had discussed this before, that if certain angles correspond and our triangles are congruent, that those angles must be the same. Or if certain sides are corresponding and our triangles are congruent, those side lengths must be equal. So the corresponding parts of our congruent triangles must be congruent. And we're going to use that in our proof today. However, underneath you'll note that before we use a reason of CPCTC, we must first prove congruent triangles. So let's take a look at how this would work. On my first proof, I'm given that PR bisects angle QPS and angle QRS. You'll notice what I'm trying to prove here is a little bit different. I'm trying to prove that segment PQ is congruent to segment PS. Well, would you agree that segment PQ would have to be congruent to segment PS if my triangles were congruent? So that's going to kind of be our plan. And we know that we start out with our given, and we're going to just take a little bit of a shortcut here, be a little bit lazy, and just say that we would copy that down on our step number 1. Now, what I want to point out to you is if PR is bisecting, this is actually an angle bisector. So it's bisecting angle QPS. If I come over here, my angle of QPS, if it's bisecting that angle, well, I can mark, it actually means that this angle and this angle would have to be congruent. It's cut down the middle. If I make those markings, I'm going to come over here and put that in my proof. I'm going to say that angle QPR must be congruent to angle SPR. Why would that be the case? Well, that is because of my angle bisector. However, I also see that it says it is bisecting angle QRS. So it is also telling me that it bisects my angle right here at R, which would mean that this part and this part would have to be congruent. And so I can go ahead and state that as well. In fact, I could put that in the same step if I wanted. Angle QRP congruent to angle SRP. that we both know the same reason is because of that angle bisector. That's pretty much all of my givens will tell me. So when I look at that picture, I'm going to see if there's anything else I can mark. And hopefully you saw this already, but we do have a shared side. So if I mark my shared side, I'm going to go ahead and state that segment PR must be congruent to segment PR by the reflexive property. And I can't yet quite say that my PQ and PS segments would be equal, but I do see that my triangles are congruent. So I'm going to go ahead and state that my triangle of PQR must be congruent to triangle PSR. I have shown a shortcut. What shortcut did we show? Well, we have angle, side, angle in both triangles. So I know they are congruent by angle, side, angle. Now, because my triangles are congruent, wouldn't you agree that side PQ must be congruent to side PS because they correspond? And so I'm going to state as step number 5 that PQ must be congruent to PS. Why? Because the corresponding parts of congruent triangles must be congruent. Or my reason? CPCTC. Let's look at another. Proof number 2, I can see we have WY bisecting XZ, and XY is congruent to XZ. This time, you'll notice what I'm trying to prove. I'm trying to prove that angle XYW is congruent to angle ZYW. We know that we're going to start with our givens, and so we're just going to go ahead and take this down here. WY bisects XZ, and XY is congruent to YZ. Well, I'm going to mark my congruent. If we have this bisecting, this time I have a segment bisector. YW is bisecting XZ, the segment. So that would really mean W as my midpoint, that these two segments are equal. And so I'm going to go ahead and say in step number 2 that XW must be congruent to ZW. This time by definition of a segment bisector. Now this proof actually could be written in a couple different ways, but most of you would probably see my shared side. And so I'm going to go ahead and say WY congruent to W, or YW congruent to YW. Again, it's a shared side, so we're going to use the reflexive property. Now, where are the angles that I'm trying to prove? I'm trying to prove XYW and ZYW. I'm trying to prove these angles right up here. Well, again, these angles would have to be the same if my triangles were congruent. And in step number 4, I can go ahead and say my triangles are congruent because I've shown the side, side, side shortcut. So I want to show you, I'm going to say triangle XYW is congruent to triangle ZYW by side, 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 which would then allow me to say angle XYW is congruent to angle ZYW. Notice step 4 and 5 are different. Why are my angles at the top the same? Well, because they correspond, and the corresponding parts of congruent triangles are congruent. let's practice a couple more. On the back side, it tells me that AD is the perpendicular bisector of CE, and CD is congruent to CA. Well, they've marked CD congruent to EA. I'm trying to prove that segment AB is congruent to segment DB. Okay. Starting with our given information, here I will point out to you that AD is the perpendicular bisector of CE, meaning CE is the segment that is being cut in half. And so I'm going to go ahead and state that right now. These two segments must be equal. CB must be congruent to EB. Why? Well, definition of my bisector, this time it's a perpendicular bisector, so I'm going to include that. Now, if I'm trying to prove my segment AB congruent to segment DB, I don't necessarily know that B is the midpoint of that, so I can't state that right now. I see vertical angles, but in this case, it would give me side-side angle, and that wouldn't work. But because this is a perpendicular bisector, we do know that those are right angles. And so in my proof, I'm going to go ahead and say that angle CBD equals 90 degrees, and angle EBA equals 90 degrees. That again is due to my perpendicular bisector. Can I prove those two triangles congruent? In order to do that, I need to use one of my shortcuts. This is a shortcut that we sometimes forget about, but with my right triangle, do you see that I can actually prove these congruent with the hypotenuse leg shortcut? Now, in our textbook, you would probably see it stated as triangle CBD is a right triangle, and triangle EBA is a right triangle. And they would state that before using the HL shortcut. Once that's stated, now I may say triangle CBD is congruent to triangle EBA. What shortcut? Well, we're going to use hypotenuse leg. And in the end, if I have those two triangles congruent, then my segment of AB and my segment of DB have to be the same. Therefore, AB must be congruent to DB. How do we know that? Well, the corresponding parts of congruent triangles are congruent. Okay, one more. You'll notice the proof statement here. I'm actually trying to prove that KL is parallel to MN. And as I take a look at my diagram, I want to prove KL parallel to MN. It tells me that J is the midpoint of KM and NL. So we know that is our starting point. If J is my midpoint here of KM, we know those are the same. Of NL, we know these are the same. But if I make those markings, I need to go and put that into my proof. So I'm going to say that KJ is congruent to NJ. NJ is congruent to LJ. And I'm going to put that in the same step because it's the same reason. It is because of my midpoint. Where do I go from here? Well, I wanted to point out in this picture, there are many possible triangles. There's the littler triangles, but there's also the bigger triangles. And sometimes, depending on what you're trying to prove or what your given information is, that's going to affect which triangles you use. Now, because I have my two segments proven congruent, I'm actually going to take a look at using what I'm going to say the triangle on the top and the triangle on the bottom. So I'm just going to try an outline in here. I'm going to use this triangle and then the triangle on the bottom. Now, had I been given different information to begin with, I may choose different triangles to use. But the reason I'm going to choose those is because do you see that I have some vertical angles in the middle? Now, in order to help me with my yellow triangle and my orange triangle, I'm just worried about the vertical angle here and here. Okay, so I'm going to say that my angle of KJL must be congruent to my angle of MJN because they are vertical. And now, in fact, I have congruent triangles. Step 4, my triangle of KJL is going to be congruent to triangle MJN because I am showing side angle side. So I'm showing SAS shortcut on both of those triangles. Where do I go from there? Is that enough to say if I have congruent triangles, KL must be parallel to MN? Well, in fact, it's not. It's not quite enough. How do we know if lines are parallel? This actually goes back to using some of our angle pairs. Would you agree that if I take a look at my diagram, I do have some alternate interior angles? There's a couple sets, but let's just take a look at using this angle here and this angle here. They correspond. The angle here at K and the angle at M would be corresponding, and so they would have to be equal. And so in my step number 5, I'm going to go ahead and say that we know angle LKM must be congruent to angle NMJ or NMK. You could say that either way, I guess. Why do we know they are equal? Well, we know they are equal because they are corresponding parts. But because those are equal, that is actually enough information for me to say then that KL must be parallel to MN. Why is that? Well, that's actually the converse of the alternate interior angles theorem. We said if our alternate interior angles are congruent, then my lines must be parallel. So in order to prove my lines parallel, I showed congruent triangles, and I showed these corresponding angles were equal. Those corresponding angles happen to be alternate interior, which meant we can say that these lines